So we have another AIME problem now. So this is a number 10. So the number of second degree polynomial f of x, which with integer coefficients and integer zeros for this polynomial f of 0 is to 2010. Okay, so since we know the polynomial is second degree, and then we have two integer zeros with the integer coefficient. So our like polynomial might be like this: f of x is equal to, let's say we are gonna have a number a times x minus the first solution. I'm gonna call that r times x minus second solution. So let's call that s. So the solution of this polynomial will be r and s, and then so we can have these two factors. Since we are told the coefficient and the zeros are integers, so this a has to be integer as well. Okay, so let's keep that in mind. And what we are also given, f of 0 is 2010. So if I plug x is 0, right, so then I should be getting like 2010 equals a times negative r times negative s. So that means this is gonna be 201 times 10, and then that's the 201 divided by 3. So 3 times 67 times 2 times 5 equals, so that will be negative, and negative that's positive, so that should be a times r times s. Okay, so now we have three numbers, a, r, and s, and they are all integer, and we need to know the number of ways to assign these like prime numbers into these guys. So like we can just have like 1, and this could be 2010, and for other like variations, I can have 3, 2, and remaining of those product. And we just want to know how many ways can we achieve this, right? So like just ask yourself, like we have like 4 primes, right? And then one of these will be part of A, any of these actually will be part of A or B or R or S. So one way to assign these would be like 3 is this guy and 67 is this guy, and then 10 is this guy. So we can have something like that, or we can have any other variation. I can have some maybe like 10 is this one, and maybe this is 3, and then this is gonna be 67 and stuff like that. So the goal is to find the number of ways to achieve this product. So this is just some example of doing this. But the question now, we can have this 3 can be going into one of these 3 numbers. So which means for this number, we have 3 options, right? And then for this 67 can be part of A, R, or S. So we have 3 options for this guy as well. So that should be 3. And then 2 and 5, we have 3 options for each of these as well. So which is going to be 3 to the 4th power. So we have 81 ways to assign these numbers into one of those 3 like numbers. Okay, but also we have like other cases, like we can assign these numbers in a way that the product will be still the 2010, but maybe these numbers might be negative as well. Like if I choose all of these are positive, so this is the number of ways I can do that. But like just ask yourself, like if I have R, like A and S, these are the 3 numbers, and then when we multiply, you get a positive number. So we could have positive, positive, and positive, or 2 negatives and 1 positive, but this positive one could be any of these. So we can have like this way as well. So I can have plus, negative, and negative. So there are 4 ways to get the positive result, but the sign will be changing. And then when you change the sign of each of these number, then you get different like basically polynomials. So there are 4 different ways. And then for each of these 4, we have 81 ways to achieve this. So we should have 81 times 4 ways to like find the number of polynomials. But we have to be careful as well, because like when you choose the numbers, you can maybe swap those, or you can just get the same like polynomial. So when you swap like two roots, let's say a like R and S like 2 and 5, x minus 2 and x minus 5, so which will determine a immediately. But if you swap those, you actually get the same polynomial. So which is why we have to kind of think that as well. So, and also some of these like three numbers are like, and I mean the roots, I would say, is the same. So what are those? Like if I choose a is equal to b, which is equal to 1, and in that case, a like, I mean, not a and b, so I'm gonna say R and S would be same. So the R and S is equal to 1. If this is equal to 1, right? So that's gonna be just one polynomial. There is no swapping. And the same thing with R S is equal to -1. If this is -1 for both, and then there is only one polynomial, not two. But for the other one, so which is we got right here 324. So we had 324 like ways to assign these like three numbers, like A, R, and S. But out of those 324, two of them are gonna have no swapping. So which is why let's subtract that from this, which is gonna be 322. And the remaining numbers can like have two swapping, which means like A, like the R and S could be swapped, and then that will give you the same polynomial, which is why we have to take this half and then add our two other polynomial that will not have any swapping. So that should be like 150 plus this would be 162, 161 actually, right? And then plus 2, so which is 163. So this is a quite challenging question, but if you kind of think about it a bit carefully, so it wasn't too bad. So I hope that was clear. I'll see you next week.